My name is Leaf from XS Software. We are going to learn how to mint native assets, an NFT collection, on top of the Cardano blockchain. In this video, you will gain knowledge about tokens on Cardano. You'll learn how to build simple minting transactions and how to submit them to be added to the blockchain. And you'll also learn the basics around accepted standards for non-fungible assets on Cardano. To make this process simple and beginner-friendly, we are going to use an open source tool funded by the Cardano community called the Mesh JavaScript SDK. This JavaScript-based tool works with all Node.js compatible runtimes, and we will be using the Bun runtime for simplicity. To install Bun, click the link found at course material number 1 below this video. Choose your operating system and package manager. For this video, I will use Homebrew with macOS. Let's make a new directory and initialize a TypeScript project with the Bun CLI. Now we can install the Mesh SDK from npm. Let's open up your text editor of choice and navigate to the directory we just created. To perform this action, we are going to need a Cardano wallet. The Mesh SDK provides us with a helpful function to generate a new Cardano wallet using the brew function. This returns a string array mnemonic, or a list of English words that when compiled create a Cardano wallet private key. We're going to log these words out separated by a space. And let's also derive a public address of this wallet. We can do this by instantiating a new Mesh wallet class using the mnemonic we created and setting the network ID to Cardano preprod. This is Cardano's testnet network. By running the script, we're going to get our important values. We're going to get our mnemonic, and we're going to get our public change address. I'm going to copy the mnemonic and put it in a .env file at the root of the project, which is something Bun automatically detects and injects any .env values at runtime into process.env. In order to make changes to the network, it's important that we fund our wallet. This is so we can pay our transaction fees. Our public address that we copied earlier, we can head over to the Cardano developer documentation, which has a preprod testnet faucet feature. You can find a link to this in the course materials number 2 below this video. To build transactions, it's important that you can read the current state of the Cardano blockchain. So instead of running a node locally, we're going to use a cloud provider called Blockfrost. A link to this service will be in the course materials number 3 below this video. Create an account with them and then create a new free project for Cardano preprod. Copy the API key provided, and we're going to put this in our .env file. We're now done with setup, and we're ready to mint our native assets. To build this script, we will leverage 3 important classes from the Mesh SDK. The first is called the Blockfrost provider. This interface allows us to read the blockchain. We're going to pass in the Blockfrost API key we retrieved earlier. This is existing in our environment variables, process.env.blockfrostkey. Next, we need to build out our wallet. We need to use the mnemonic we put into our environment variables, and let's turn that back into a string array. And now we create a mesh wallet, similar like we did earlier, using that mnemonic. And this time we use a provider for our fetcher and submitter. Notice how, again, I use the preprod network ID, that is network 0. Here, fetcher refers to the provider that fetches the on-chain data. Submitter is the provider that submits our transactions to be added to the blockchain. In this case, both will be Blockfrost. Now let's explore our third important class, the transaction builder. This abstraction allows us to quickly compose Cardano transactions without having a low-level understanding of how transactions work on Cardano. We will also use Blockfrost as our fetcher. Let's obtain some basic information about our wallet, including the first address and the current UTXOs. A UTXO is the way value is represented and held on Cardano. The sum of all the UTXOs of a wallet is equal to the total value the wallet holds. Let's also grab the public key hash of the wallet, and to do this, we'll use a helper function called deserializeAddress. Now we must write what's called a native script. On Cardano, every native asset has a policy ID and it's derived from the rules used to mint the asset. There are 2 main ways to define rules for minting assets on Cardano. The first is a smart contract. The second is a native script. sometimes referred to as forged script. Forged scripts allow for very simple rules to mint your assets. We're going to define two rules. The first is that the token must be minted before slot number 90 million. The current slot on pre-prod is 88,809,773. The second rule is that the mint must also be signed by our wallet, and we can use our pub key hash value to verify this. Now we convert this native script into a forged script using the Mesh SDK helper, and the policy ID of the token can be derived from the forged script using a utility function resolve script hash in the Mesh SDK. As discussed earlier, we're going to create an NFT collection. Let's mint 9 unique tokens, and we're going to perform this mint all in a single transaction. For each token, we'll give it a name of asset number X, where X is 1 through 9. And we then need to compute the hexadecimal representation of each token name using the Mesh SDK utility. Now let's make a call to the transaction builder and mint a single token of our policy ID with a name of the hexadecimal. Each time we perform this mint, we need to attach the minting script for reference. We can complete this transaction by attaching the address that will receive the tokens on mint, and we need to make sure that the transaction is invalid after the slot defined in the script. Then we select UTXOs from the list we grabbed earlier, and after using the complete function, we obtain an unsigned transaction. And we could use our wallet to sign this transaction, and after, submit it to the blockchain. This will return a transaction hash we can use to view the transactions on chain. Now, we could stop there and not add any metadata to this transaction. All wallets and explorers would display the name of the token, but it wouldn't contain any metadata, like an image or attributes. If you're going to mint NFTs, you likely want to add attributes and also images to accompany the token. Let's define a type to express the metadata standard. The Cardano community has standardized NFT metadata in CIP Cardano Improvement Proposal number 20. A link to the standard is found in course materials number 4. We'll have to have a policy ID header. Nested inside, we'll have an asset name. And inside nested is the asset metadata. Let's define this type and create a helper function to make this process more clear. Asset metadata contains an array of files, which contain a media type, name, and source. They also contain a root image, media type, and name, alongside a freeform list of attributes, which are completely user-defined. To explain this, let's make a function that generates 721 metadata, given a record of attributes and a name. I have already found a PNG hosted on IPFS that will suffice as our NFT collection artwork. In this collection, each of them will have the same PNG, but with different names and attributes. The outer image and media type is used as a thumbnail for the asset. We can now, inside our for loop, add the metadata for each asset to our object to submit alongside our transaction. We are now ready to build and submit our transaction by running our program. This will return a transaction hash we can validate on-chain. Let's head to a Cardano Explorer and find the mint transaction. You can see all the metadata provided and the 9 assets being minted. Now let's take a look at what the assets look like in a popular Cardano light wallet, like Lace. You can see all 9 assets with a thumbnail provided, and each with a unique custom attribute. Congratulations! You have successfully built a program that mints an NFT collection on the Cardano blockchain.